My name is Connie Schaaf, and I teach high school math and science. I teach all the way from Algebra 1, College Algebra, Trig, and Stats, and I also teach physics and chemistry. And one of the things that I have a passion about is showing the kids where they're going to use the algebra in real life situations. And one of the things that I found that works excellent is to take my physics or my chemistry or both and integrate them into the algebra classroom. The kids like nothing more than to be able to put their hands on something and collect data, graph data, and then just interpret what it means. And so in this activity, we actually are using buggies as the first one and looking at constant motion. And then we're going to use Hot Wheels is actually what we actually put on a ramp and look at the velocity and acceleration there. So the first thing that we're going to do is I'm going to go through and show you a PowerPoint that the kids actually did, which is an accumulation of all the information that they come up with. And then I want to show you some clips of the kids actually doing the lab and a couple of the kids speaking. So let me show you. So this here is an example of the data that the kids collected. And you can see that they ran this car approximately 8 meters, and we always do 3 trials. So we're talking about finding average as one of the things that we did. And these values here, so this is your line of best fit and your correlation coefficient that we talk about. We do use the Desmos app. If you've never used that, excellent app for the students to use, and I think you could probably go all the way to about 3rd grade with it, and they could use it pretty easy. So one of the things that they had to do was they had to take each of their cars and draw a distance time graph. And you can see with this one, the kids' data was very good. It made an excellent line showing that we were doing constant motion. And so one of the things that we do is we take this and we talk about a distance time, and the distance divided by time is velocity. And so we relate the slope of the line to the velocity. The next thing that we did is we took 2 different cars. In this case, you can see the blue car and the blue car running against each other. And I tell them that if they started 12 meters apart, facing each other, where would they hit? And so they actually wrote systems of equations and graphed and found the time that it would take for them to crash and where they would crash. And so they marked it on the ground, and then we tested it to see. This was another one. They were doing the blue and the green car, because I do have multiple cars so that they can see. Some go fast and some go really slow. So here again is some kids' data looking at velocity and time. So the first graph up here at the top is their collection of distance and time. This one is for on the ramp that it's going, and in which you can see that the data is not as linear here. And one of the things that they also had to do is they had to draw some conclusions. And so the kids will have conclusions that they have to make as to why. So on this one, they said on the ramp, the steeper the ramp is placed, the steeper our quadratic will be. Since it started a little before the line, it had already begun to accelerate. Therefore, the line will be quadratic. And so we talk about, why is it not quite quadratic? What was things that could have been messed up? And then we also take everybody else's data and put together. And the same way here, what should it look like? And the fact that this one should have been constant. So again, I just grabbed somebody's data there to show you. And so these are examples of what we do.
Hi, my name is Aspen. I'm in Mrs. Schaaf's advanced algebra class. I'm going to be talking about a buggy lab that we did earlier this year. We set up 2 different situations with these buggies, one where the buggies were going in the same direction and one where they were going in opposite directions towards each other. We found things like velocity and the curvature of the buggy to determine when the 2 buggies would collide. After we calculated and got the numbers, we used a slow motion video to time
activity was where we put multiple mechanical buggies on the floor and recorded how long it would take for the mechanical buggies to get to different spots on the floor. These were important in our algebra use because we were able to figure out the velocity of the car going down the ramp, and that the pull of gravity was what was affecting the acceleration of the car.
That one's still. Told you we were faster.
As you can see from this video, kids love getting buggies, whatever the case may be, and playing. It's as if they're playing with toys, but in fact, they are learning a little bit about math, physics, and other subjects.